I had so much energy yesterday, and now I'm like, I guess it's just Friday.
Great way to start off the podcast there.
Let's have a little meditation moment. If you're riding in your car, don't close your eyes, but imagine you're at a waterfall. The water's trickling down. A fairy appears from behind the cave. There's money in the fairy's hand. It flies over, whispers in your ear.
I have no idea where you're going with this.
It's called improv, man. If you jump into the river, I will deposit this money into your business bank account.
Immediately jumps in.
But I don't have a business bank account, you say to the fairy. I'm tired. This is not the beginning of the podcast. I'm just tired. It could be. Let me just gather myself here for a second. I drank last night. Yeah. Dude, I went home last night and I was like just wanting to do nothing with my brain. So I was like, what Judd Apatow movie am I going to watch tonight? And then I was like, oh, I want to see Hangover. And Hangover is not by Judd Apatow. It's by Todd Phillips, who did The Joker, which is pretty crazy because they're opposite movies in some regards. And instead of going to Chipotle and getting like a thing, I went to Mighty Quinn's, the barbecue place. But they have like a bowl. So it's like a great alternative to like Chipotle if you want like a good meal, like a healthy meal. I mean,
Mm-hmm.
But they have like, you know, they're the ones who have the brisket at Smorgasburg. You know that brisket with like the salt and they just like smack it and like the fat jiggles and you're like, I can't wait to get that inside my belly. It's delicious. They do barbecue, but it's really good. But they have one in my neighborhood, and you can get a bowl. It's like rice and like brisket or burnt ends with like a little bit of barbecue sauce, and they have like sweet potato casserole, and they have like broccoli and bacon. But they have some healthy ones too, like just broccoli and like just roasted sweet potatoes. So I did that. That's
nice.
Like it was great. It's like a great alternative. Like that's the one part of the West Village I don't like is there's not a lot of like fast food, like quick meal. Healthy options. There's like all these sit down places that are super fancy, right? Anyways, I was pretty excited about it. And they have a lot of good stuff if you want to go for a cheap meal too. But they have like just good chicken. You know, it's just like an alternative. We'll go next time we're in my head because it's really, really good.
It's good, yeah.
Oh, yeah. It's delicious. Like the brisket and the pulled pork and stuff is being made all day long. It's like legit good barbecue. And I know good barbecue.
Yeah.
Ish. I've never done Texas yet. I know Texas brisket is apparently where it's at, but I've done South Carolina, lots of South Carolina barbecue. Georgia, Florida has good barbecue as well.
I don't really know barbecue, so I'm just going to take your word on all this.
It's all over the place, man. You know, like the palates are really different in the different states. Like mustard-based, like vinegar-based, like
so it's like
sweeter.
It's like the sauce. Then.
Yeah,
Okay.
The sauce. It's very different in the different regions. I like the vinegar-based. It's different. But yeah, apparently, just the brisket in Texas is supposed to be good. I love barbecue. Well, we grew up, you know, like when you tailgate and you're a college football fan, that's like what you are eating every weekend. So, but Mighty Quinn's is surprisingly good because you come to New York and you think like it's like the worst place to get barbecue, right? But
yeah,
Mighty Quinn's is great on like the faster food side. There's this place in Williamsburg called Fet Sow, which is like unreal good. And then I've been to a place up in Harlem,
Dinosaur.
Yeah. Which is a fun spot.
Unbelievable.
Yeah. So, but I think Fet Sow is my favorite actually. So good. But I guess it's not that hard. You know, just get the fattiest piece of meat you can, put it in a slow
slow
cook
and
it,
slow.
yeah, for hours. But anyways, so yeah, I'm just tired, man. I'm just tired. I don't know why. It's because there's no more nitro cold brew. WeWork. Everyone's wondering if and when WeWork is going to shut down. Well,
these are the warning signs.
Yeah,
no
exactly.
more nitro cold brew.
No more plastic forks. We have metal forks now. No more full size coffee cups. We have mini. Look at your little mini cup over there.
No, this is a normal cup. I just have really, really big hands.
I think you would get made fun of in middle school if you drank coffee out of a cup that looked like that.
I think you'd get made fun of in middle school if you drank coffee.
That's true. I wonder if middle schoolers these days do cool things like what's the hip thing to do? You know what the hip thing to do for middle schoolers is today? Because my niece is 13 years old. She wears sweatshirts that look like they're $10 champion sweatshirts. they look like the kinds of black sweatshirts with the Champion logo that you would buy when we were their age for like literally $9.99. And this year I got them for a Christmas gift, and they were like $60, and they're super in vogue, and they just look like crummy old 90s hoodies, and that's what's in style right now.
90s clothing is in style.
Fila, Champion, a black sweatshirt with the Friends logo on it. No joke. That's like super trendy right now. Did you start recording that?
Yeah.
Okay, we've talked about so many important things now. I wouldn't want anyone to miss it. Yeah, it doesn't make any sense. I guess everyone does it, right? But is like NBC. It's like low fashion from our time growing up in the 90s and 2000s is now trendy, hip fashion for kids.
Do you think someone at NBC is like, wow, our Friends merchandise is like off the charts. What the hell is going on?
I'm sure they know exactly what's going on.
Yeah. It's a long game.
Hot take. Is Dependabot good? LOL. Next.js. Tell me what's going on with Next.
We covered Dependabot.
Yeah.
It's pretty cool. I've gotten like a world tour of all these different frameworks doing the Mirage stuff. So if someone will ask a question like, I can't get Mirage working with Next, and I just immediately go and try to make it work.
We thought this was going to be so fun because we get to learn Angular and Vue and React and Svelte, and really we just get to fight build setups.
Yeah. No, it is. I've gone through a bunch of tutorials, a bunch of getting started guides. I think it is cool.
Yes.
Just getting exposure to this stuff.
Yes.
Next, I wanted to talk about Next. I didn't know much about Next before last week. And, now that I've done the getting started guide, I'm an expert. My view of Next was just like I heard Guillermo on Adam's podcast. My view of Next was like it's a framework that's made to be deployed to like now to edge servers. It does server-side rendering for like your React components. It's meant to be fast. I've always that's just sort of been the view in my head. It's meant. I don't know what that actually means.
But it's like a application architecture plus deployment architecture. It's like a application and deployment architecture in one, which is why like when we were learning React, it wouldn't be like start with a Next project. That's not really in the same category as like a create React app.
Yeah. Exactly. That's how I've always viewed it. When I got started with it, I realized that it is kind of create React app. Which is interesting because I would never compare these two. And I realize that, at least my take is their positioning is so focused on edge deployment, speedy websites. You can write JSX, but you should also have a server rendering aspect of that if you're going to go down that road.
Mm-hmm.
And I was really blown away that they, not by the tech, but by the positioning that they take. Because I think it's going...
It was an example of the importance of positioning given that the tech wasn't as different as you were thinking originally.
Yeah. Going through setting up a Next.js app, I realized this is basically a Webpack config, right? Like at a 100,000 foot view. Now, of course, they're doing a lot more, but it is basically a Webpack config. And you could compare it to something like Create React app. But I would never, I wouldn't do that. To me, these two things are uncomparable.
Yeah.
Because of what you said. I look at Next as like a deployment and application architecture for deploying to the edge.
Yeah.
I look at Create React app as like I'm building an SPA. And the fact that Next was able to differentiate themselves like this, I think is really, really awesome.
Interesting.
I think it's really, really impressive.
Interesting. So, which is why I've always kind of been confused. Like, if I build an app with Create React app, can I deploy it to now? And of course, I know that you can because it's like a static asset at the end of the day. But at the same time, like now is always talking about, runtime server stuff, things like that. So
it's even interesting. Like,
that's why I've always deployed my Create React apps to Netlify and not now.
Right. And even like you could replicate the now Next setup using Create React app and Netlify. However, or Gatsby and Netlify. However, you wouldn't why? if you think about like I want to build a React app that runs on the edge and is made for speed. Like in my mind, like why explore anything other than Next as your first try at this?
Yeah, but Gatsby gives you a lot of different things. Gatsby is like a higher level than Next.
Again, my point is that like you
are not setting yourself up for success to be positioned to take advantage of the architecture of Zeit in the same way that you are just by buying into Next.
Even if you are, when I think about like why I would use Next, I don't think, oh, okay, like I could use Next or I could use Gatsby or I could use Create React App. Like I think very specifically like Next is made for this problem and I'm going to use Next.
Well, which is why we weren't even considering Next for the website for Mirage.
Yeah.
Although in retrospect, well, it's different now that they have this option to generate a server-side bundle or whatever. And there's things we don't like about Gatsby, so it might be an option. But from a marketing and positioning perspective, it was not really. Gatsby was clearly a better fit for the kind of site we were building.
Yes, and I think this is a good thing.
Yeah.
That Next takes this position.
Yeah.
Because
Next doesn't say
Next doesn't say, oh, we could do that.
Yeah.
We could do that. Next is very clear. Like, and also too, like after I kind of realized after using Next and going through this, I like went through their docs and there's really nothing in their docs that say what I'm talking about. There's nothing in their docs that say like, oh, this is like made for deployment to the edge. It's more just how the people that work on the project talk about it. The types of things they tweet about, they talk about on podcasts, their whole now infrastructure. It's such great positioning.
That's really important. I think I was just watching this beginning of this video series from the future on YouTube about branding, and when they are like run this digital branding agency. It helps companies like rebuild their brands or rebrand their products and stuff. And they always talk about what a brand is, and a brand, in their phrasing is that it's the gut feeling people have about a product or company, and how do you influence it. So if it's a gut feeling, you can't change your brand, because you can't change directly someone's gut feeling. In that way, a brand is not like a logo that you can just change overnight. You have to influence someone's gut feelings. You don't have control over it. And so the way you do that is through all of what they call the customer touch points. So every customer touch point is an opportunity or a chance or a time when you are influencing the brand. And so that's why it made me think of that, what you said, because when you see Guillermo tweeting on Twitter, you would be like, oh, I shouldn't, that's not like connected to Next, except it is, because they're associated together. And obviously his values are going to influence who he hires and the kinds of things that are important to the people who work on Next. So that, in all of that in totality, creates a brand, a gut feeling that people have about project like Next, which is that it's for like a fast React site that might need to do runtime server rendering. And so when we're building a site like Mirage,
that does.
Like,
that does need to do.
Or like that might, from my needs, is that a need of ours that we have? And like for MirageJS.com, it wasn't at the beginning, and in the near future it wasn't. So that's why, like, whereas if we were building something like a real-time dashboard for the iPad in here, that seems like it's pretty interesting, because I know at a high level, even if I haven't gone through the tutorial, I can do API functions right there. And that was just like gravity and ice that made that.
Oh, I was wondering what that was.
I know, it's weird. I think it just melted enough to move. That if we needed some API functions or something like that, you know what I mean?
Yeah.
So whereas like, it's almost an interesting thing, which is like, what's more important, the byline on the homepage of Next.js.com or Gatsby.js.com, or the fact that like thousands of people have just been saying Gatsby's good for blogs and Gatsby's good for content sites for the last 2 years?
I mean,
the latter is way more
important. Yeah. It's a positioning.
Yeah.
So
it's kind of interesting. And it just goes to show you, like, if you're in the position of running a brand or running a product or company, sometimes how much of an uphill battle you have, because you could put all the time in the world to the homepage content. And if people say your thing is for something that you are missing the mark there, that's exactly what this whole video series was about. Was he was saying the brand wasn't coming through in the way they wanted it to. And you don't have control ultimately over the brand, since it's in the minds and the gut feelings of the users. So how can you best influence that? Maybe with a better logo that communicates what you want it to, maybe with better marketing materials. It also reminds me of something you said this week, which was like, we're seeing a lot of people using Mirage. It's been pretty cool if people are just trickling in and using it with different tech stacks, even though, we're talking about it, but it's just, it's kind of organically happening. I guess people are just discovering it in a variety of ways. And a lot of people are getting it running in development. And the testing story was at the origin of Mirage and is such a huge part of it, if not the biggest part of it. Given that like the HTTP boundary is so hard to control, especially in a place like a testing environment. And there's like, testing isn't even emphasized in the docs. Like there is a testing section, but it's past the core concepts. And there's so much more we could say about testing in Mirage.
100%. Going back to what you say, like we're not influencing people to think about testing. We might just have a few bullet points on testing.
Right.
Yeah.
Right. So that's just good to chew on and think about. So yeah, kind of interesting. Cool. So do you like Next?
There's one more point I want to make about Next. I've been battling it for the Mirage integration, so that's like, affecting my lens.
We should talk about that.
Yeah, we will. We'll get to it. The Next quick start was the fastest I've ever gone from reading like a quick start, getting started web page to actually seeing output of code that I wrote on the screen. And it made me think, like, I wonder if this is why it's so popular, because like you start to explore it and all of a sudden like you have an app.
Interesting. Can you walk through the steps?
Yeah. So normally like with like Ember, Vue, Angular,
Create React App,
it's like, oh, run this command to scaffold your app. Part of that command is like installing dependencies.
So npx space create React app space my app. And then that sets it up. And then you're like, you have to like, that like scaffolds out a package JSON for you. Then you actually have to install that package JSON. So right there, it's like we're already like a minute or two into this. Then it's like, okay, now you want to like, you have a SRC folder in that. Yeah, you CD into it, you yarn start, you wait for that to start.
Yep. Got an SRC folder. You've got like a main or an app.js. You've got an index.js that does like the bootstrapping. You have like your app.js. That's your root component. You go in, you edit that, and then you see the code. By the way, that sounds like super easy and super straightforward. As soon as I went through the next thing, I was like, holy crap, those other CLI tools, they're like take ages to get started.
Interesting.
With. So with Next, you already have a node project. So they just assume you already have a package JSON, and you yarn add Next, and then they give you a script. So it's like Next dev
that you paste into your scripts key of package JSON.
Yep. And then you create a component. You have a pages directory. So you would create pages index.jsx, and you would return JSX from that, and that's it. And then you do next dev or whatever the yarn
script
dev.
Is.
And you go to localhost 3000 and you see that output.
And
it was, there was like no,
So how long does it take to yarn add next? Is it fast?
Super fast. Yeah.
Interesting.
Yeah. Yeah. It really, really surprised me how fast I was writing code. And I was thinking, I was like, I could just keep writing code right now. Yeah. And then like all of a sudden, oh, look at that. Like my app, I just chose Next.
Right.
I'm using Next to develop my idea, because there was like never any point where like I got stuck, or it was just, it really felt like I opened up the website and then all of a sudden I had an app.
Interesting.
Or with these other tools.
It's pretty cool.
With these other tools, it's always been like, find this file, open it up, add in the first line here, which is fine. Like, right. It's if you're going to scaffold out someone's app, you need to do that. I'm not saying these other tools are making a mistake. They're not.
Right.
But yeah, it was like I'm developing an app and I don't even know it.
Yeah.
It was a very cool feeling.
Interesting. So what does Next actually do? It's just providing like the build stuff. It's like looking at pages and...
Yeah, it's like a Webpack. So basically I'm a week into this, right? Not even 4 days. They give you like a file system based router. So you have a pages directory. And if I made pages / my directory / index, that would give me a localhost 3000 / my directory URL. So I can just create JSX files, TSX files, and I automatically have a router for those.
Got you.
The second thing is they have on your components, you can add a static property called get initial props. And that's going to be the props that are first passed to this component when you server render it. And so it makes server rendering like really, really easy.
And it's promise, like it takes a vendable if you need to.
Yeah, I think you can return a promise and it will wait for the promise to fulfill.
So if you were fetching data on the client, would you use that? No, you would use like a use effect and fetch.
So you can do both, where you fetch data in both the use effect and in the get initial props, and then so you'll render on the server, and then you'll also fetch on the client, and it should no op.
Oh, but
similar to like
the work.
Similar to FastBoot.
Is there a way? But you can't.
Yeah, there's probably a way
rehydration.
I think they have. I haven't done this yet, but they have examples.
Yeah.
Yep. They have examples of stuff like this. I'm not sure if they go that far as a shoebox, but you could make
caching the response on the server, and then have you seen any examples of fetching data on the server with get initial props? Like your server is making a request to another server, so it's like not slash. It's like you need like a
yeah.
How does that work?
So they use like isomorphic fetch.
Okay.
In their example, so this is fetch that works on both Node and the browser, and you'd be making you're not making a request to the next app. You'd be making a request to
API server.
Yeah. And again, with like my understanding of now, you'd probably want that also deployed on the edge, so your edge front ends aren't going back to some origin to fetch their data, because like defeats the whole point.
Well, you can put API routes in the next app too, right?
I haven't gotten that far, but
I think you can. But then eventually, if you need to talk to like a database or something, that can't go on the edge, right? We've talked about that before.
Yeah, I think I've heard Guillermo say you should use databases that do support being on the edge. So they're like Amazon has an offering for this where they have like an SQL database that you can access from anywhere.
I see.
So
I thought I saw him tweeting recently about like the idea of like server side rendering, runtime server side rendering, just being like he doesn't even believe in it anymore. Like if your app needs data at runtime, you should just ship an app shell and let the client fetch it. Because why make the server fetch it first? Because then you can't do edge deploy. Basically, his whole thing is like, what is the most that we can ship to the edge? And then everything else, let the client request it directly.
Well, I mean,
I don't know his arguments, but I think that's what he was saying recently.
I think you can design an application that lives 100% on the edge. I've heard him talk about this before. So you can have a database that lives on the edge.
Well, you give up some things. I mean, you can't just do that with no trade-offs. I mean,
right.
Yeah.
Right. And even if you can,
I mean, let's just say that your application you can't show stale data.
Well, okay. I was going to say, we might be able to bend these trade-off curves in a way that, okay, you're always going to run into cap theorem, but we might be able to bend these in a way where like you don't have to think about stale data. Like if there's a chance that you're going to get stale data, maybe like your server blocks the read. And so even though you're reading from the edge, you can't read from an edge if there's like a chance it's stale. I don't know if like that's realistic, and I don't know if you actually can build a database that has that guarantee.
I feel like the way the hardest version of this story is to have an app that needs real time, what is effectively real time data, right? So yes, if I deploy the app, if I change some static data in the index.html, like, and you don't have it, it's stale. But effectively, right, that's not the domain I'm talking about. I'm talking about real time data. So an app shell is always the same for everyone, and it's fresh. but then there's content that is effectively real time.
But
that's the kind of app that would put the architecture to the test.
But then we're not. But this goes back to how I started this podcast. Like then next and now are less interesting to me. If I always have to go back to a central data source and I lose all this running code on the edge.
Well, I'm just saying, let's take the hard case, which is an app that basically requires real-time data. I'm not prescribing it has to go to a centralized data store. I'm just saying, I'm saying that isn't that the implication? If you're taking this kind of app that has real-time requirements, showing the stock price of Apple real-time on a second basis, you're not going to be redeploying that thing to the edge every second, are you? That wouldn't be practical.
No. But the idea is your code that's running on the edge has a low latency, like physically close to the Apple stock price. So it can ask a server in its data center, what is the stock price of Apple?
And how does that know?
Well, so this is where this turns into a black box with like.
Let's say it's your data. It's your data. Yeah.
So you're like designing this thing end to end. Well, like
you own the source of the truth. Like it's like, what's the temperature in EmberMap's office? And we're going to build an app everywhere that's going to update real time.
So if we wanted to make this so it could run on the edge, we wouldn't have all of our application code like asking the thermometer in our office what the temperature is. We would revert this and we would say, every time
invert it.
Yeah. Every time the temperature changes, we would push out the temperature to all of our edge servers.
Yeah.
So that way when the apps can always ask a database that like lives right next to them.
Okay, but what if that what if it's up real time?
You actually have to go to the thermometer in the office.
Yeah.
Yeah, in that case,
going to the intermediate database that happens to be close by doesn't matter because the update frequency is so fast.
So then this whole argument of edge deployment becomes silly, and we over-architect our application because we have this constraint.
Well, it doesn't become silly. His argument is not that you you introduce an intermediate database. His argument is the way to think about this is you have two alternatives in the event you're talking about a real-time app as I've described it, right? Mm-hmm. One is to basically do a Rails app, right? Let's say you were building this as a Rails app. And so when I request the data, and the data has to be so fresh that it cannot be duplicated, it cannot be sharded or whatever, shared across databases that are local to the app servers, there is a central database in Virginia that has a source of truth. When the client makes a request to the Rails app server that is close by, you have to make a request to a centralized database, and then the app server gets the response and then sends it to the client. Mm-hmm. What he's saying is that is one alternative, but the other is you do the app shell model. And if there is such a request that must be so fresh that it cannot be gotten at the edge, push the request off until the last second when it's on the client side.
And the client goes to Virginia.
And the client goes to Virginia. Exactly. So that was I'm pretty sure that was his argument. I'm kind of scrolling through his Twitter and just seeing if he says it, because I'm pretty sure he said basically, that's when he says SSR is like, no, he thinks you don't need it anymore. That's what he's talking about. Not like you should never send HTML to the client, but more like, if your servers are making runtime requests, just let your clients make the runtime requests instead.
But why?
Because you get the app shell fast, because it's just a conceptual clean boundary that the app shell is like.
You get the time to first. You get the first paint faster.
Yes.
Because you get to render an app shell where, but
it forces you to think very clearly about what can be cached and pushed to the edge and what is needed at runtime.
Okay, that's fair.
Are you like thinking about TED or something, like how it would work?
Yeah, well, the architecture was similar. The architecture was similar, right? Even though there was
databases and Rails app servers, they were
but they were used as like edge servers.
Yeah, and it was just there to make it easy, because you don't have to build it.
So
but they can't be deployed to a CDN, so I guess that's a difference. But I mean, maybe it's. What would it look like there? That's actually a good test question, right?
Wait. I wonder. So in that case, you should always start by not server-side rendering.
Correct.
Rendering on the client, and then if
server-side generation, you would say, sure, right? Like,
no data fetching on the server.
Correct.
Always rendering.
No
on the
runtime
client.
server rendering.
Right. So then your app always works.
Right.
But it might be slow in the sense that, like, you see a loading spinner for 30 seconds.
Yeah. But you would see the time to first would be faster, but it could potentially be slower than waiting for a full Rails request from an app server that does server-side rendering.
But at that point, it lets you opt in to solving that problem.
Right.
So you can say, like, we're going to have an intermediate database.
Exactly.
Or guess what? Real-time data is not important.
Exactly.
And we can serve from cache.
Exactly.
Okay. That's
kind of interesting, right?
That's a good point.
Okay, but now to take the other side, right? Because say you have an app, that's the extreme, right? Take one in the middle. That's like a bread and butter app, like the kind we worked on before, where you just it's a Rails backed, database backed app because it's just it could be cached. It's not like the data changes so fast that it can't be cached, but it's like relatively complex, and like we've seen that it's like way simpler if you just generate, like, server-side rendering is very simple in the sense that, like, it involves trade-offs, but like it also is just, I visit the homepage of Twitter and I fetch the latest tweets from the database and I give them to you, and like that's extremely simple, right? Mm-hmm. So like, if you had an app with a lot of views, I mean, does any CRUD operations here like basically violate the constraint? I was just thinking, like, you hungry over there, buddy? Yeah. Putting the database, like we've done and we've talked about in 8 different places around the world, close to where the origin is or whatever, or close to where the origin of the request is. Like, if you took a complex Rails app and tried to like pre-render it and cache it, that wouldn't really make sense if it was a very dynamic app, right?
I mean, yeah.
So you wouldn't do that. You wouldn't do that.
Right, but this is not what you just talked about. Is not that. It's deliberately
pre-render and cache the outer parts.
It's what you said. It's deliberately thinking about
which parts you
can cache. Yeah. So app shell.
Yep.
And then letting the clients fetch data.
Yeah.
The really nice thing about this, I don't think I was understanding, was it lets you do that and then optimize later.
Yeah.
With server rendering the data fetching.
Yeah.
And that's real.
Wait, what do you mean? Like what we do in EmberMap?
No. You can render app shell.
Yeah.
Have all your clients fetch the data. So maybe this is suboptimal because you get instant, fast time to first paint, and you get 100% on Lighthouse.
Right.
But the reality is, your users have to see a loading spinner for
30 seconds.
Yep. And that's obviously not the case. But we're
it's
just
slower.
Extremes, right?
Yeah.
And so now you can say this 30 seconds for the loading spinner is we need to change this.
It's a problem.
It's a problem. So how do we do this? Mm-hmm. Well, we can cache that data at the edge.
Yeah.
And our architecture is already set up to support all this because we already have these concepts of caching the app shell at the edge.
Data doesn't change, that changes infrequently enough. Yeah.
So
like the app shell
itself. Lets you build
have that conversation and build it in that way.
And you build on top of all the work you previously did.
Yeah. Instead of, if you took a typical Rails situation and then wanted to start caching bits of it, it would be hard because all the dynamic parts, it's not clear.
Yeah, you start running.
Your default is just everything runs through a Rails app server. It's not being built into static assets.
Right. It's not clear with Rails what you would do here, right? Like there's tons of custom architectures that you could come up with. So that's that.
It's pretty clear to me. Vagrant or whatever the thing. What is it?
Varnish.
Varnish, not Vagrant. Varnish.
Yeah, but
I'm kidding. That's part of that was a joke. It's like there's a million ways you can go about
that is
speeding up.
So if you think about it, though, like you could reproduce this next architecture with Varnish,
where you selectively,
where your Rails server renders HTML, right? There's just one Rails server. It's sitting in, I don't know, Ohio. It renders HTML. You have Varnish on every edge node.
Yeah.
It goes back to origin. Yeah. It gets that HTML. It caches it.
Yeah.
And then when it serves that HTML to clients, the clients then make fetches for data, and they go back to Ohio with their fetches to get their real-time data.
Yeah.
So you get that next model of like app shell fetches from clients, but that's tons of custom code that you now have to maintain.
Yeah.
It's a whole entire architecture that you need to maintain.
Yeah.
So
yeah,
it's really
it's pretty interesting.
Yep.
So I guess what I was trying to get at is like in the event that so if the data query on the client takes 30 seconds and it turns out that it's not real-time data and that therefore can be cached, I agree you have the architecture set up. Just cache that response at the edge and then boom, it'll be a lot faster. Or you could even go further and do what we do in EmberMap, right? Which is like instead of like keep delivering the app shell and just make that initial data request fast, just basically embed it in, let the thing know ahead of time even, right? That's like a server-side generation kind of thing. We just know that we can go ahead and like pre-render this thing. It's still put it at the edge. It's just like you could optimize it even more, what I'm saying.
Yeah, get initial props.
Yeah,
could the first time it runs could actually do a fetch request back to Virginia. However, the second it could remember that in like literally in its module scope. I'm not sure if there's like a sandbox or to prevent data leakage here, but assuming there's not, just like set a variable like last fetch response equals this.
Right.
The next request that comes in, you just serve last fetch response, and you don't actually make that fetch.
Right.
But again, the powerful thing here is that your architecture is already set up
totally
to support
100%. No, that's a great like victory. That's a great success story for this architecture. My question is there a case where the client requests the data, it takes 30 seconds, and it's getting fresh data, fresh-ish, maybe real time or whatever, but it would be faster for the server to fetch real-time data. So what's the case there?
This is a very theoretical argument that probably won't hold up. But so you can imagine that, let's say you're using Amazon to serve everything. Mm-hmm. So from the edges, from your central servers, from your origins, everything's on AWS. So in a world where the edge serves the app shell and then the client makes a fetch request back to like Virginia to get the data, you are now, that fetch request is at the mercy of the client's like ISP.
And it's just like generally in like a unauthenticated, like it's just in a hostile environment.
Yeah, that's
basically.
Yeah. Sure.
You have more control over your servers in general.
Yes,
so
that fetch request could be coming from a cell phone on a mobile network, where if it's running on the server, that fetch request is coming from a server in a data center. So yes, absolutely. It's more hostile environment. And
might require more round trips to get like signatures, whereas your server could already have that, let's say.
Yeah, who knows? Freaking knows what this ISP is doing.
Yeah.
So the idea of your edge code running its fetch request, it's probably that network, like if it's all on AWS, that network is probably optimized. And so
for server to server.
Yeah, it's just like, it's all within the same network, right?
Yeah.
Now, again, this is a very theoretical argument because that might not actually be faster.
Right.
But that would be an argument for why clients shouldn't fetch data.
All their data. That's all their real-time data.
Yeah, more. I actually like saying more hostile environment.
Yeah.
And I think it actually describes the situation.
Yeah. Well, it is. It's way less privileged, right?
Yeah. But I don't.
It's actually not even that. I was just thinking the way to counter that is like the initial shell that's delivered. No, it is less. It is less privileged because the shell is being delivered at the edge, not by a server. It's being delivered by a server.
Server at the edge, though.
Okay, but it can have like the session. Let's say it could have like the session, the shell, even if it's with this edge. But it couldn't have like session data that's like tied to like a real time thing.
Yeah, if you need to like verify the session in the database to make sure
person hasn't been fired or something
exactly,
like that.
Exactly. It doesn't have that.
It doesn't have that.
You need to go back.
Right, because that's real-time data.
Again,
we need a better name than real-time. It's like runtime data. It's like basically real-time is a constraint. You do not accept stale data here is what we're talking about when we say real-time, right?
Yeah.
So in the event that the data query that's taking 30 seconds, the real-time data needed relies on some privileged information. If you had the architecture where you had like a Rails server that was distributed, you could imagine it having secrets or something like that that would make that thing take 15 seconds instead of 30 seconds or whatever. And so even though you're not taking advantage of the edge, it's actually faster because...
I know.
But thinking about the real world apps
yeah,
we
again,
built,
this is like, this argument just won't hold up.
But like, what about like uploading something to, like, what about, uploading something to S3, like... We treat. So you would get the signature
you would get the
from the server, but it's real-time signature. So it would have to go anyways. It would have to go to origin.
Well, this is actually a great example of what you were saying before. It's something that you can start off with. The client is going to get the signature to upload from S3 it's going to go all the way back to Virginia to get that signature.
Right.
Because you have one single app server that can sign stuff.
Right.
And then it uploads to S3. Maybe that's a little slow because you have to go from like
Japan,
Australia, Japan to. But you can always optimize this where you start shipping your server code that can generate signatures.
Privileged server code.
Yeah, you can start shipping that to the edge at some point, right? So we can start off by.
So there's privileged server code that is stateless. It doesn't need the database, a central database, right?
Correct. Like generating signature.
Like generating a signature.
Yes.
Yeah. It's something that client code will never have.
Correct.
But that also is not in the same category as the kind of question, is Ryan still employed here? That's a centralized database question that cannot be replicated across the edge.
Right.
And if it's real time.
And this goes back to CAP theorem.
Right. So interesting. So yeah. So the argument would be start with this architecture where you start with edge deploys everywhere and only talk to origin as needed.
Right. Get initial props basically always returns nothing.
Right.
And then as you need to speed things up, you can start using get initial props.
Right.
As
you need real time. Once you need real time data. Because get initial props is right, exactly. So just do it from your client code.
Yeah. Do off it. Okay. And that's how, And
which is basically how we've been building.
You don't need SSR.
SSR. That's, if you think about how we've been building Ember apps for the last 6 years.
All like, to be fair, all SPAs.
All SPAs, yeah. But it's just that
that's the other
deploying
thing.
app servers around the world has been part of making apps fast for a long time. So to realize that maybe that's not what you need is the interesting part of all this.
There are other things here where there are other reasons to SSR that are beyond speed. So even if your site is slow, you still want like links to look good on Twitter and in Slack. So you need SSR for that.
Yeah. But that's more like SSG, right? Well, you're saying no, real-time data.
Yeah,
to
if
SSR.
I have like a URL that's post/post ID,
right?
I need to go. My server
you need a
needs
block
to
on
be
the server rendering it.
My server needs to be able to generate that. Again, this is
so you can't take advantage of Edge and CDNs. We can't take advantage of CDNs, but you can take advantage of Edge.
No, you can. You can take advantage of Edge. You need to like be thinking of caching at that point. So when you're
If the data needed to generate to SSR is real time, it's the same problem. You roll back to the same problem.
And when I say caching, I mean all forms of caching from your node edge code can remember that like post ID 1 has these OG tags to you have a database that's meant to be accessed by edge servers.
Yeah.
I'm putting both those things in the same category, even though one is like really low level and the other is like super abstract.
Because they still, they have to do with the data frequency and the fact that you're allowing clients to access data that's old, but that's okay.
Yep.
Right. Pretty interesting.
See, I kind of like this. Like this is making me excited about why not adopt this approach, even if we never, ever use get initial props.
Right. Because
why not adopt this? Like, is there any downside? You get server-side rendering. Your client can still fetch data. And if your server-side rendering depends on something like the current user, your server-side rendering just basically, there's like if statements in your JSX that just make sure you get an app shell.
Right.
there doesn't seem like a downside to
right.
like.
And again, the apps we've built with Ember, we always put them on a CDN, and so it's just that usually they have a white screen because we like block on the initial application hook or something like that, but we don't have to. That's just like a. If you look at the architecture,
we deploy from CDN, but we don't SSR from CDN,
right.
So we can't app shell.
Right.
So we get destroyed in like the quote like time to first meaningful paint, where like a now app, a next app would just destroy us because they get instant. I mean, not instant.
If it was cached, if the initial request was cached.
No.
Walk me through this. So EmberMap start a brand new Ember app for EmberMap.com, and the homepage queries the latest 10 videos, right?
Yeah.
We built it. We built an Ember app. Model hook on the application route does a store.findAll movie list of 10, filter by 10.
So we have
a Rails app and we have an Ember app.
No, our edge server serves that Ember app.
So we build the Ember app, we deploy it
to a CDN,
assets to the edge, but goes out.
So the time to first byte, super fast.
Someone in Thailand clicks embermap.com.
Super fast because they get it served off a toaster in the neighbor's apartment.
Right.
That's how efficient our CDNs are. However, now they're going to execute that Ember app, and they're going to hit that model hook, and that model hook is going to be a fetch to API/movies.
Yeah.
And now, maybe through proxies or just through a direct call, that thing now has to go back to Virginia.
Yeah.
And so while that request is going to Virginia and then coming from Virginia back to Japan, the screen is white.
Right.
So we have no now we.
So we have to avoid the router or blocking promise on the route.
Yeah. Take some time to build a loading template, right? We have to actually think about what we're going to do during this, and I mean, you would in any app, I guess.
Yeah, loading template. That's fine. Ember has APIs for that. That's fine. So you build a loading template. Yeah. So that's basically
So you get the basically instant render of the loading template, and then slow render of the data fetch.
Right.
Now, in the next case is going to be very similar, where you go to the server and you get back HTML, but you only get back as much HTML that your app can generate on the server. And since we're not doing data fetching on the server, we're going to start with the thing that you started off this conversation with. The client is going to fetch all the data. So you get back an app shell. So that's super fast. And then maybe your app shell can say like, oh, if you get back an app shell, and then your code runs on the client, and that generates a loading template because the code on the client is going to have an effect that does a fetch to Virginia, come back, and you get all the data. So I think like the actual movies will appear at the exact same time.
Yeah.
However, I think in the next case, you will see a paint slightly sooner than in the Ember case. Because in the Ember case, you have to download all the JavaScript and start running all the JavaScript to get the loading screen. But in the next case, you can start rendering the loading screen right away because that HTML is generated on the server.
Oh, because it's you have a server at the edge that can generate static, non-real-time data. Oh, okay, I see.
So now, so this is
okay. I understand. You're not just deploying things to CDN, static assets to CDNs. You literally have servers running at the edge.
Yeah.
But the point is that for non-real-time data,
you have servers running at the edge, and the servers aren't doing. All they're doing is like we can just
they're doing static things.
Yeah,
they're like static servers. Yeah, they're it's pretty cool. And then you're already at a point where you could actually. The nice thing is that the architecture is ready for you to do things like cache of FastBoot data response that is from origin but expires in a day at the edge already. Whereas we had to basically write our own node servers to do all that and figure out to deploy them. I mean, is our node layer deployed? It's not. Yeah, because that would be hard. I mean, that's like more work. Like, how do you even do that?
The funny thing is we could do that, but our hosting provider doesn't. Have such an offering that we can take advantage of.
Yeah.
So
that was a lot of words to to avoid saying.
No,
sure.
Because
I understand.
We use Heroku, and Heroku is amazing.
Yeah.
And I love them. Heroku's optimized for Rails apps that need to access a database,
A central database.
So this idea of being able to take your dynos or your containers and just deploy them
around the world
doesn't make sense
not built into
for Heroku's customers.
Yeah.
So
Yep.
I'm making a lot of assumptions
Sure.
Just knowing what I know of Rails just doesn't make sense.
Sure.
Maybe in a world where we start using databases that are distributed and they have the same guarantees that Postgres has, we'll start to see more of like the Rails Heroku providers offer
adopting
that
this model.
Yeah, where you can take a Rails app, put it in a container, deploy it anywhere, and there's just a guarantee because the database service you're using is always going to have a local.
Because the Rails app server is not distinguishing what kinds of the static work it does from the runtime work it does.
Yeah.
Whereas like in this case, you do have that boundary, and that boundary is your JSX code versus get initial props. So that's a hard boundary between dynamic and static work that needs to be done on whether it's on an edge or not.
Client versus edge.
Yeah, exactly.
So this goes back to what I was saying where when we started this podcast off, I was saying, well, there are use cases where you wouldn't use Next, but now I'm actually, are there use cases where, like, would it be bad?
This seems like a good boundary to know about from the beginning of the app development.
Well, my question is, would it be bad to build the Next app that you never did get it? You never used.
Would you have been better off using something other architecture?
But maybe not. I mean maybe it's fine
because you're already going to be deploying it.
I mean, is there any downside? Like, what have you done extra work that you don't need? Have you made your architecture more complicated?
Now, okay, what about what about the constraints that make this all work? What about the routing stuff? Because isn't there some routing constraints that you have to comply with once you use Next? For example, like the nested routing stuff and the fact that like everything's code split and bundled by route, by URL. Isn't your URL handled by Zeit and now, as opposed to like something like React Router?
Yep.
Because they don't want your application to ever be a bottleneck.
So
wait. What about rights? So let's talk about.
Can I just make like a statement here? Yeah. Can I just say those are not get initial props and having all your routes be mandatory code split?
Not mutually.
Yeah, exactly. They're not
intrinsically dependent on each other.
Right. So the code splitting is...
You should be able to have one without the other.
Yeah. So the code splitting is something that...
a further optimization decision that they imposed.
Because they believe this is the fastest way to render an application, which sure, that's fine.
Okay.
But I think you can still do
You can opt out of that route splitting thing, get a single SPA the way Mirage.js is built, JS.com is built, and use React Router and have every route render the exact same bundle of application code and have React Router do switches based on the URL and then render the right component.
And still have
edge deploys.
And still have get initial props.
Yeah.
That you can decide what to do.
Yeah. You can do it static, get initial, like at the edge, get initial props, or block on going to origin or whatever. So that's cool. Okay, what about rights? Let's think if this architecture makes rights harder, because this is what we've been talking about reads the whole time, and it makes sense. But
okay, let me just start being dismissive, and then you can correct me. I think with rights, it's first of all, like speed with rights, I think is less important, just in general. So when I click the submit button on a form, if it takes 750 milliseconds versus 75 milliseconds
versus a link, clicking a link and having it take 750 milliseconds.
I think there's like I think the form, just most application developers don't need to be concerned with that. I think it also probably really depends on like your data requirements and your database architecture. Like if you actually have to do...
Like Slack, if you're building Slack, 750 milliseconds wouldn't really be acceptable for a chat message.
Yeah, I was thinking more along the lines of like, if I'm going to write something, if I have to go back to the database and confirm before I enter this thing here that like you haven't been fired, and this thing already hasn't been entered, and all this other data is correct, then that's always going to have to go back to origin.
It is.
It's always going to have to go back.
So
to
let's take that. That's a hard case, though. Signing up for a new user and making sure that your email doesn't already exist in the system. So that is a hard case. So let's think about that and if this architecture would have any effect on those code paths. So if you had a Rails app and you did that, okay, you just check the database, boom. What about the fact that...
let's say the user clicks a submit button in Tokyo.
Yeah.
It goes to a Rails app. The Rails app handles it, checks the database, says everything's okay, generates a response, and sends it back to Tokyo.
Now that's one Rails app. Let's say you go the TED route where we have 8 Rails apps around the world. So it has a copy of the data, but again, this is a write case, and we can't accept any stale data. So even though you have a database copy and a Rails server running over here, you still have to block and go back to origin, right, to check the central thing.
Yeah, in Rails, you can do like Rails folks that do this. So you can have like 2 database adapters, one for reads, one for writes, and the read one is hooked up locally. The write one goes to Virginia. And by the way,
that makes sense.
This is also back to like, you can do a million things.
Yeah,
here.
It's kind of like Daddy. It's
tons
like, it's
of custom
not,
architecture.
There's you're not gonna find this in the Rails guides.
Yes,
yeah.
Correct.
Yeah. So you're blocked anyways. Okay. So what was I gonna say? This is an interesting one. Let's take the case where you have one Rails server, one in the whole world. It's running out of EmberMap's office, right? So it takes
thermometer in the office.
Yeah, exactly. Or just user sign up, right? Because the unique email is an interesting thing, right? So Japan creates an account. It's all happening like request response cycle, one single source of truth, one database. So it checks it and is able to do it. But now someone else, right, makes a request like half a second after that user was created. So this is an interesting one. And so they're going to see something fresh, and it's going to be accurate because it's coming from the single central data store. The new user was just created over here, so that read is up to date. So this is the thing where it kind of breaks down. If you take the edge deploy Zeit architecture situation, you're basically saying, in order to take advantage of the Zeit architecture, you need reads to be able to be stale. And so if you have a situation...
No.
If you have a situation where a read needs to be real time, it's basically if either a write or a read needs to be real, basically all writes need to be...
There's no big advantage.
Yeah, exactly.
Okay, I agree. I agree with that, but I also want to say,
who cares? I mean, that's
there's
the
no
point.
Big disadvantage.
Yeah, that's the point. I mean, that is the question.
So why not?
Yeah, I'm trying to. I'm just thinking out loud. I'm trying to find: is there a disadvantage for situations where But would it make it more complex if you had a read that needed to be real time? Let's say that was based on like new users that are just signing up. Then that would just mean that would be true regardless, and it wouldn't be served at the edge. It would be generated at the origin. And it's just the truth.
One is a request response cycle that gets a full HTML payload from a Rails server that lives at origin. The other is a fetch request that gets data from a server that lives at origin. They both have like the same latency profile, and that they both have to go back to origin.
I mean, isn't this like Git? Isn't Git lets you do everything you possibly can at the edge, and then like operations that require you to go to origin like are blocked by that, but that's just because that's the nature of those operations, and that's why Git is like fast for most of what you do, because you're running at the edge.
Yeah, you are. Yeah, Git. But by the way, every time we talk about this, it's always awesome to be able to tie this back.
I know. Well, I was already thinking about. As I was trying to think of disadvantage, I was like, what if you had a Rails app server in a database and you were able to do like log stuff at the edge? But then that's the same thing. You can still deploy that to the edges. It's just
Git lets you do all reads and writes from the edge. So you clone a repo, and then every operation you run on that repo is that repo on your computer. And Git basically says
doesn't let you do all operations. Continue.
Okay.
You can't push a new commit to master for that you need origin. That's an example of a
But-
real
but-
time
but-
needed.
You can't. You can commit to master.
Yeah.
You can't
Commit
push
to origin,
origin.
master.
Right.
Yeah.
Right.
So that's that's an example in the set of all operations you can do
Right,
that
okay.
is like needs real time.
Sure.
Yeah.
But you can
It's an important one.
you can do all reads and writes on your local
Sure.
Git repo,
Sure.
and then you can at a later point push and
Sure.
resolve conflicts. But you lose the real time. For this podcast,
Yeah.
what we've been calling real time data. So, for example, if I check out a Git repo, you check out a Git repo, you start editing yours, I'm not going to see those.
Yeah. Exactly. That's a great point. So the designers and creators of Git evaluated the trade-off and said, we're going to sacrifice real-timeness for the ability to work at the edge because it's way faster. So yeah, that's a decision you can make, and you can see how that can influence your app's architecture and your tool's architecture. It's pretty interesting. So like,
but it's really cool that like imagine that by default. So I'll try to tie this into Zeit. Imagine by default every get command you ran, it was like SVN and it went back to origin.
Yeah.
And it tried to run that on origin.
Yeah.
And if it was somehow invalid, you would get an error.
Yep.
Imagine if that was a default.
Right.
And then as you want to make these trade-offs,
Right.
you can then layer it on. So you can say, okay, so everything's going to be default, go to origin. But if you run git commit with a message WIP, I'll just do it locally.
Right.
And you as you as an application developer get to carve out those pieces that you want to be local.
Right.
That's pretty cool.
Very cool. Yeah. Yeah. Very cool. Yes. Very cool. I still feel like there's a case where, the signature case or the fact that the privilege case, again, you still have privilege. You can still have privileged servers at the end. They just can't be, they can't rely on runtime data. I'm just trying to think of an example where like, the TED architecture wins.
Well, let's just like be uncharitable, right?
Yeah.
I'm saying like, is there a downside to this? And like, yeah, there is a downside that you're locked into Zeit.
Yeah.
Right.
But that's fine. No, that's.
But we can start there and expand outwards, right? That's like the most uncharitable.
Mm-hmm. No, it's more, but the more interesting conversation is around, should you start working in an app with clear boundaries between what is static and what is dynamic?
Okay.
Right?
Here's a hard to do. Your data needs to be real time, but you also have to server render for Slackbot and Twitterbot.
Yeah.
So now you need to basically have some sort of cache for bots.
Yeah.
So that you can actually get the SSR layer working, and so that your edge servers are doing fetches to get data. But then for users, it needs to be real time, so that you basically have a whole nother code path where all the users are running JavaScript and fetches on the client.
Yeah.
So that could be like, at that point, why not just use Rails?
You were saying the users need real time, but what you meant was the Slack needs real time.
No, the users need real time.
Okay.
And Slack needs OG.
Wait,
users need real time data.
Yeah. So that
And Slack needs users need real time data, and Slack bots need server generated pages.
Yeah.
So I guess, what does that look like
with the Rails app?
Well, what does that look like with the Next app? Like, you have get initial props, it does fetch, and you just do server side rendering. Like, how would you build this as a Next app?
And you're saying for the case where you want to speed it up for the bots, you have some logic in get initial props, or you don't run get initial props if the referrer is like a Reddit bot or something like that. Whereas if you were writing a Rails app, you wouldn't be thinking about any of this because every request would be served exactly the same way.
Right. And there'd be for the user's case, there'd be no difference in latency profiles. Now, of course, okay, the time to first byte would be faster.
No,
in the edge case.
It would be faster than the edge case. That's important. It would be faster.
The time to first byte would.
Yes.
So app shell would be faster, but like actual data would.
Yeah.
Like
correct,
latency
correct.
for.
But you get the app shell.
You get the app shell,
Yeah. What can be deployed at the edge is going to be by default. That really is the benefit of this entire architecture.
But in this, so the pro is you get the app shell faster.
Yeah.
So looks better for your users.
Yeah.
The con is that
you have more code paths.
You have code paths, right?
Yeah.
Right.
You're
So if
thinking
you were just writing a Rails app, the con is you don't get the app shell, but the pro is you're serving the same content to everyone.
If you're just writing a Rails app, by default, real-time data is not a question. That's why when you're building like an admin, it's like it just works.
Yep.
And the question is, when you're building an average app, how much of the data needs to be real time? Are users expecting to be real time? But even in the case with the Zeit architecture, you just need to be thinking about that from the beginning. But the argument is like it's actually good to, because like then you just get to speed up the things that do not need to be real time from the beginning. They're going to stay fast, and the pages that need to go to origin can, and they just do so by being requesting it from the client.
Yep.
And it's simpler because it's just
Also, too, like this would have made EmberMap a lot easier.
Oh, for EmberMap, it's like a no-brainer. But really, the hard one is like an internal back office tool. Like some of the projects we worked on, where it's like, why is this not updated? We didn't have that because we always wrote it. This is where those problems would surface. But again, it wouldn't surface because you would just say, if you try to do that, if you had a dashboard, let's say you have a productivity tool that has like companies, users, whatever, subscriptions, and you're just basically your bread and butter back office app. And all of that is real-time data for, again, in the description of this, in the definition that we've had for this podcast, which is when someone clicks on products, they want to see the latest list of products. When they click users, they want to see the latest version of the user. It has to come from origin, has to. No way around it. Then you build a dashboard, and the dashboard is like doing this massive query, and which happens a lot in these kinds of pages, and you want to start caching it because it's like looking at all this data. So the dashboard, you just want it to be, so maybe if it's not real time, let's say if the dashboard is not real time,
if you have a single origin
you would be able to use get initial props. It's a really nice, graceful thing. You say, let's speed up this one. Okay, this dashboard component, get initial props, and now you can make your edge server cache that. Let's say it goes to origin the first time, or let's say it pre-computes it on deploy or whatever it is, right? Now, boom, dashboard blocks on get initial props, and eventually it's all there at the edge, and it's stale, but that's fine. You can decide when to bust that cache, and that's pretty cool.
Yeah.
Whereas if you were in a Rails land,
you could cache it, but the caching would have to take place on origin,
right?
And
all the other, right, exactly.
So now you have that extra hop, and that extra hop could be like halfway around the world.
Wait, so okay, let me think, because so all the other pages are real time. So for effectively the user seeing it at the same time, except now the dashboard is like computed and derived, and it can be a little bit of stale. And you're not really in a spot where you can just take advantage of that fact. Like, this is a new fact that this part of the app users would rather have much faster and stale than slower and real time. And so when you run into those situations, like, what is the path to that, to taking advantage of that fact? And with like a Rails app or the way we built EmberMap, like, there's a lot of work to get there.
No. But in Rails can cache that.
Yeah.
And Rails has awesome caching mechanisms. So like Rails can cache that, but if you're in Tokyo, you still have to go to the Rails server to get that cached version.
Yes.
So like, and then so Tokyo goes to Virginia back to Tokyo. So
you don't have to talk to the database.
You don't have to talk to there's no database, but we're in a single origin Rails world.
So if you were to put a bunch of Rails servers around the world, that would be effectively the same thing. I mean, that is the servers at the edge. It's just that Rails is not built really to do that.
Sure. Yeah, exactly.
You can't really run the Rails servers at the edges without a database. So now you have to set up a database, whereas you don't actually want that right here. You really just want to push out this cache value. It doesn't even matter. You just
Also, of course, you can do this with Rails, but you just have to make a bazillion architecture decisions that are going to be different from everyone else's.
And also, you haven't been thinking about or been forced to think about this from the beginning, whereas with the Zeit model, it's literally you're starting from this from the beginning, in the sense that if you just say real-time requests are made from our component code, all of the parts of the React app that are static are just static by the fact that they are, and they're going to be compiled down into JavaScript and HTML, CSS. We're going to get them server rendered statically, and so it's going to be a server generated app, so that a lot of the loading and all that stuff is going to the shell, as much of the app as possible is going to go there. And then when you get to this point where you need this dashboard component, you want it to be cached, you want to make that trade-off. Take away the real time, give me some faster speed, boom.
I've got get initial props, and I can import, my special caching module,
right,
and use that and get initial props. And
pretty awesome.
Yeah,
it's really cool.
And the question, we can keep. Is
it's
there
deliciously nerdy too?
Is there a downside to doing this? And I mean, if I like, one way to test this is you write a Next app and you never use get initial props. Is your app worse off?
Right.
And the answer is probably no.
Yeah.
I mean, just from like an architecture point of view,
right,
not from a like vendor lock-in or anything like that.
I have a question. Can you use Create React App with Next.js? Because like Create React App gives you a bunch of,
I think Next.js
test sets up. They maintain a bunch of things.
I think Next.js is equal to Create React.
Does
App.
Next give you testing and stuff? Doesn't give you anything like that, right?
I haven't hit anything like, I haven't needed to do anything like that, so I don't know the answer. I think you can. What we've been talking about this episode is both Next and now.
I guess. Yeah. No,
right.
I know.
So
I guess it's like if you had a Create React app, how would you tell it how to server render it?
Yeah, it's up to. I mean, you would.
So that's why you want to use Next, because they're just going to say
exactly.
The components here are we're going to server render them.
Yep.
So like they don't run use effect on the server.
Correct. In SSR mode, use effect does not.
Pretty
run.
cool.
This is an interesting thing.
Also, we were talking about the Ember model, which has some benefits here.
Right. This is an interesting thing between the Ember and
server rendering.
Everyone else. Also, I think the Ember model is better.
It's really cool.
But let me. All the others are like, I've heard people in the FastBoot refer to them as like single shot rendering.
Yeah.
So this idea that as soon as you start generating HTML, you can just pipe it right out to the client.
Okay.
So you imagine you have a template that's like component A, component B, component C. As soon as component A renders its HTML, you can send that out to the client. Now, if component C has like
an asynchronous code,
has an effect in it,
right,
that goes up and changes context, that would change the rendering of component A. It's like, too bad.
Right.
It's just single shot. So that's why use effect doesn't run.
Interesting. Or anything asynchronous.
Yeah.
Wouldn't have a chance to
yes, or anything,
have a chance.
Or anything asynchronous. Now, server-side rendering in React components can have a static property that fetches their data, similar to get initial props. So
in what? In
React, in server-side
what's it
rendering.
called?
I don't know. Data, something like that.
This is something that's part of React?
Yes, part of server-side rendering in React.
Okay, interesting.
So you can do that.
And it's like the model hook, basically.
Yeah.
But you're not using that to build your client app.
Well, that's
so
where this is why the Ember
FastBoot
model
is really
so
cool.
much better.
Yeah.
Ember actually runs your app, and at some point decides I can flush this out to the client. Now, of course, there are trade-offs here. You can't start shipping your Ember HTML until you've rendered your very last component, because the rendering of your very last component could have changed the rendering of your first component. So this kind of puts us in like a weird spot where we don't run FastBoot at runtime because it's slow, and it's slow for things we're doing. It's slow for things FastBoot's doing, but we cache our responses because we don't want to run FastBoot at runtime. And I think one of the
hold on, but I don't think that matters for the purposes of this discussion, because if you were using Next and the Zeit architecture, you wouldn't want the servers to run the React code on the server. I mean, it doesn't really matter, but you would probably listen. Hold on, let me explain. Let me finish.
Yeah.
By definition, the code you're running on the edge is static and doesn't depend on runtime data. So why wouldn't you have a caching layer?
No, it does.
No, it doesn't.
Explain.
The by definition, what we said is like the code you're pushing to the edges is static. It doesn't depend on runtime. It's the app shell, right? The app shell. So,
but okay.
I know it runs in a node server,
but it could depend on runtime data, and I have the opportunity as an app developer to make that decision.
Sure. But yeah,
which is a beauty. Which is
hold on, but I'm getting confused.
There's so many models.
So so if you need runtime data, you define get initial props, and then
now you have props that will be given to your component as it gets server rendered.
No. But that's not runtime data, dude. That's not runtime data. You wouldn't do runtime data. Remember, you keep the runtime data. We need a better word.
No. A runtime
real
data.
Real time
data.
Yeah, real time.
But you
do not put the real time data requirements and get initial props.
If you want to, you can. You can.
No, but then you would be blocking. You would not get the app shell until that thing resolves. The whole point is that you split.
Wait.
Those.
Correct. But you might need that, and this is what this is.
No.
Yeah.
No.
Imagine you have you're rendering a blog post. You need to render OG tags. It's a requirement. It has to look good in Slack. So you would have
you're saying you don't have an opportunity for the client to make a request or something.
Yeah.
Exactly. Okay, that's fine. Okay, OG tags is fine. I get that. Okay.
There's a million things like this. I mean, OG tags is like the lowest level.
But that's not what's interesting about the model hook case with Ember being able to pause server rendering and not doing one shot. That's what I'm talking about. So considering that case, okay, let's go back. So Ember model hook can block. You were saying the reason we don't run FastBoot at runtime is because it's slow for a variety of reasons. My point was that doesn't matter for the purposes of this discussion, because when you server render, you're doing it because you don't need it to be fast. Because you're going to cache it anyways, so it doesn't matter, right? It doesn't matter that FastBoot is slow for us because we cache it anyways.
Yes.
And if we couldn't cache it because the data requirements were real time, we would fetch it on the client. Because of that's the whole Zeit architecture.
I know, but there is a middle in between.
Yeah.
Where you say, I need real-time data and I need to generate it on the server.
And it needs to be quick.
I mean, you always pay a latency cost when you're running
real time. When the constraint is real time. Yeah.
But yes, imagine,
or client. Yeah.
I think my point here is that the way that React server renders is going to always be faster than the way that Ember server renders, because React basically single shot. However, the Ember app, the Ember server rendering architecture, I think it's better because it allows you as an Ember developer to architect your app in one single way.
Well, yeah. Well, that's the thing. So
you get to write just one single code path, and that runs on both the server and the client, and you don't have to say, if I'm running on the server, now I need think about how like the props get to this component. So I think the Ember way is more of a black box. It's literally visit this URL,
wait until
and give me the response back. Where the React way is not like visit this URL and get the HTML output. The React way is like render these components and whatever they render, give to me.
I have a question. Let's say we were trying to take advantage of Zeit architecture using Ember. Now that we're talking about this distinction between like real-time data and non-real-time data, like stale data, let's just say for purposes, right? Stale data and real-time data, right? So think about EmberMap.com. Homepage is all mostly driven by stale data, data that can be stale, in the sense that our videos don't change often enough that we are okay serving stale data on the homepage, with the exception of the header, which is derived from the current session, which is real-time data.
Yep.
That's a constraint. So let's take the case where we're just working with stale data. You put it in the model hook. So my question is, if you want to take advantage of the Zeit architecture, would you ever put what goes in the model hook? Because normally the model hook is like, what data do you need to fetch to generate this page? But really, you want to be thinking about it differently than that. You don't want to be thinking about it if it's...
No, I like the model hook. I like the model hook because it's what data do I need to fetch to generate this page, regardless of the context that I'm running in.
So...
Where if you think about...
You see how I'm going with this? So...
Yeah, you're saying how would
Let's say the model hook of the homepage is fetch the latest 10 things, which can be stale. But then the model hook for your settings page is fetch the current user, which is real-time data.
Yep.
So how does that, see how that, there's no, the architecture, the tooling has no comprehension of the fact that the one can be cached and the other cannot. So how do you do that? Whereas,
can I ask some questions?
Yeah.
I like where you're going.
Yeah.
So you're saying you have like a black box Ember app and you just say visit/home, or visit/settings.
Mm-hmm.
Well, so the way that we would do this is home would make a fetch request to somewhere.
Mm-hmm. And the model hook?
The model hook.
Mm-hmm.
And then settings.
So visit/ wouldn't return until all the data was there.
All the data was there, yeah.
And therefore, the entire response could be cached by whoever is calling visit/, right? Okay, continue.
Well, maybe I'm going to like hand wave here, but like you could imagine the model hook does a fetch, and that fetch doesn't have to go to origin. That fetch,
stale data, exactly.
Yeah, exactly.
Yes.
So you could imagine that fetch is like
it's all the fetch is also cached.
Yes.
Yeah. Sure.
Now, again, hand wave
Sure,
because
sure.
there's some magical caching layer here.
Sure.
Now with the settings route,
But that doesn't even matter because it could go to origin, but the whole response there, whatever. It doesn't matter. Yes, it doesn't matter.
in the settings route, the model hook would say, if I'm running on the server, basically like return null.
Okay.
Otherwise, return the current user.
Okay, that's the way around this.
Yeah.
But that's kind of weird. That's not, you've lost this idempotence isomorphism or whatever that you were talking about.
No, you're right, because now you have, and that is true, because in our app we have, if we are running in FastBoot, let's take this code path. If we're not,
and maybe that's not terrible. Let's compare it to the Zeit case. So now let's do this for the Zeit case, right? So you're building a homepage that can be powered by stale data. So what do?
Get initial props basically is get 10 latest videos from cache and hand wave. Maybe that goes to origin. Maybe that reads from cache.
Right.
And it always does a server render.
Right.
With data. However, how long that data took to get, we don't know and we don't care.
Yeah. It's stale. It could be cache at the edge. Yep. So it's the whole thing can be cache at the edge.
Now with the settings page, get initial props basically doesn't fetch data.
You don't use
it.
it.
So now you force the client to fetch, and therefore you can rely on the client going to origin, always validating there's a user, always validating the request headers and all that.
To take this another way, but maybe it's the same situation, but maybe how would you normally build this, right? In the React case, like you're just working on the homepage and you say, okay, use effect. So maybe this is not being super charitable with Ember. Maybe this is actually, think about this. So let's just walk through this. Let's build a homepage. All right, I need to fetch some data. All right, use effect. Get the latest 10 things. Okay, boom. Build the settings page. Use effect. Fetch the current server, current user. Render the page. Okay, good. You deploy that, it works. Later, it's like, all right, the homepage can be sped up because it's stale. All right, now what's the refactor look like? So what do? Do you copy the fetch to get initial props? Do you pull out the use effect?
Yeah, probably pull out the use effect. Use like isomorphic fetch, so they have like the same quote API, and then abstract it into a function called get movies, and have a use effect that calls get movies as well as get initial props that calls get movies.
And then like props movies.
By the way, I am sure in the real world it is way more complicated because like it's servers are privileged, so you can make more assumptions.
Yeah. It's not
but yes,
it like in this situation,
ideally isomorphic fetch, and you're just saying fetch, and that from your component's point of view, that's all it needs to know.
Right. Props.movies doesn't care where it got it from or whatever, something like that. Okay. So then that works, and so your settings page is still real time, but now you've cached your homepage. In the Ember case, you're just building out the homepage and I need some data, fetch it in the model hook, render it, cool. Settings page, fetch some data in the model hook, build it out, render it out, cool. All right, now let's make the homepage fast.
So okay,
so this
again, we're not like this is hard to do in Ember today, but Ember
it doesn't have to be because of Ember's architecture. If we're speaking about the architecture,
right. So FastBoot has you can pass things into FastBoot. So we could pass in like like a hash that's like remember data for. And then we could like
the first time the FastBoot server
runs
on the homepage route,
it fetches the data, and then like in after model it says if is FastBoot put this data
the window.cache equals
exactly.
Yeah.
So
that's way hard. That's way harder.
I know.
And
it
doesn't have to be, but it is. It absolutely is. And also, you have to set up a node server and run FastBoot
because this goes back to there's a million architecture decisions you have to make.
It's just like with Rails. It's the same thing with Rails.
Yeah.
You could do all this, but like, this is the beauty of the.
Now, when I was comparing React,
hold on. Let's keep walking through it. So once you get the FastBoot server.
I just want to say we're at like an hour and 20 minutes.
I love it because I was like low energy, and then I was like, we started talking about edge servers, and who knew? There's a backend developer hidden deep down inside this front end developer right here. So let's finish it. So you want to cache the homepage. So you have to set up a FastBoot server to run, and you want to cache it. So first of all, you could deploy that node server all over the world, that FastBoot server.
Mm-hmm.
And now the FastBoot server doesn't run get initial props. It literally runs your Ember code. So you haven't changed any of your Ember code yet. So you run your Ember code, and the first and maybe you warm the cache or something like that. Whatever. Somehow you get cache value. Runs the Ember code. Runs the home page. Makes a data request to origin, but now it's cached all over the world.
So and like every FastBoot
instance has the stale homepage data, which is good for this case because you want it to be fast. You don't care it's stale. So that's great. And you have not had to change your Ember code at all.
It's still model hook fetching data.
Yeah.
Now you do have to change your Ember code in the sense that like in after model, you actually have to take the model and put it in the cache.
Well, the FastBoot app server could cache.
The
node code.
The node code knows no. The node code.
You wouldn't want to put routing stuff in your node code.
Yeah, the node code. There's a very strict boundary where the node code just says generate me a FastBoot and give me the HTML for this URL with these.
Let's say you make up a node server, FastBoot server, it caches everything. Okay, it just caches everything, which is basically what like the Zeit servers do.
But the FastBoot server, no, because the FastBoot server gets like HTML, gets like a string that it can cache.
Yeah.
Where Zeit can, I think you have more control in that you can build your caching and get initial props so that some renders can.
But let's take the easy case. Homepage is the same for everyone, can be cached, it's stale, so it's cacheable. You add FastBoot server, node server to your architecture that serves up the Ember app, and this homepage, it caches everything that it gets from app.visit.
Okay, so you're sticking varnish.
Because I'm going with this. Yeah, exactly.
You're sticking varnish in front of FastBoot.
Yes,
okay,
exactly.
Yes. Yep.
Exactly.
I gotcha.
So, so you haven't had to change your Ember app code. So from that side, Ember wins in a sense, right? Because in the Zeit case, the next case, you had to change the effect. You had to take the data fetching code out of the effect. You had to put it in something, attach it to get initial. You had to change the React code.
You have two paths for data fetching.
Yeah. Oh, could you change this? Because I just lost my one here.
I just got real excited.
Yeah.
Slammed down
So, that's good. So the Ember app code situation is ahead in this case. There's like 4 boxes here, right? You have the React app and the Ember app, and then below them you have the server-side changes that each architecture needs as far as architecture goes, right? Okay, now let's talk about the settings page. So as it stands, you've just broken every route in your Ember app that depends on real-time data, because the way you were nudged to build it and the way all the feedback you've gotten is that the model hook's going to run every time. There's no caching, so caching doesn't break it, right? So what do you do in the Ember? You still have varnish in front of everything. So what do you do to give the app shell to the users of the settings route as fast as possible and delay the request for the real-time data to the client? So maybe you move the data request that was in the model hook out of the model hook and you put it in a data loading component.
Yeah, exactly. Yep.
And then everything else still works.
Yes.
And so that is the difference, where in Ember, you can't take advantage of like the model hook anymore and the routing conventions. But there's like good ways to fetch data from components after the fact. So you're not going to block your FastBoot server, and therefore any of the responses that it generates. And then effectively, you do not need a runtime FastBoot server in this very simplified world I've painted, in the same way that the next one doesn't either, because it just runs it once to cache it and pushes the cache out to the edge.
Yep.
So It's pretty cool. Now, of course, if you happen to have a fast server at the edge, it is good. You can see in all the ways it would be very convenient to have that. The fact that to have a fast server at the edge. So what I'm saying is like we have a hard constraint that we do not run FastBoot at runtime. And there was maybe some things that would be convenient if we could. Whereas with the next case, like the API routes that are still like stateless and like still would have to go to origin if they needed to make a real-time data request, can do other cool things at the edge, and it's just nice that they can do that. And you could actually rely on that.
They could sign S3 uploads because we have no problem.
Exactly, a secret, pushing the secrets to the edge. Exactly. Yep.
I mean, I don't know. Like, there's like databases now that are distributed with an SQL interface. Like that.
Well, I guess that's the dream. Is that it bends a trade off when we're talking about stale versus real time. Maybe that thing is now even closer. Yep. And whereas with our architecture, really, if anything needs to be seen within the changes within the last, like, you know, like on the settings page, you'd want to know within the last like 10 seconds. And that's already fast enough that you can't use the caching architecture. So you have to bail out, and it's going to be slow, right? Whereas maybe with some of the stuff with the next architecture, if 10 seconds is okay, staleness, or 8 seconds or 7 seconds is okay, you can actually still keep it fast. Whereas with us, it's like, okay, either you have like a super fast homepage that's stale how long would it take to bust the cache of the homepage and regenerate it and make it fast again?
I think worst case is probably like 5 or 6 seconds, because we use like Sidekick to coordinate this stuff.
That's pretty good.
So in Sidekick, I think default is like a 5-second poll.
And we're not pre-warming it, so the first request would be technically
correct.
So technically, you would need to include the first request in that time. You need to add it on time.
Yes,
you see what I'm saying?
Yes, yeah.
How long until the data changes and someone gets a fast homepage response?
Right. So we would clear the cache, and let's say like worst case 5 seconds, and then a new request comes in.
And how long does it take to generate it?
And sometimes those take like 3 seconds to generate. Right.
So anything under 8 seconds is going to be slow. It's going to be real time. Anything that's under 8 seconds in EmberMap's architecture is considered real time, and therefore is going to be slower. And anything that can be 8 seconds or more stale can be very fast, which is most of Zeit, which is why it works well for us.
I see. Yep.
And so maybe with some of this other stuff, you can say, okay, anything that's 3 seconds or less. I mean, that's 8 seconds is already pretty fast. So
yeah, and it's easy to opt out and get app shell loading template,
right?
And feel fast. Feel like a fast.
No, I know, but that's not the interesting case. The interesting case is because the interesting case is like when I take an operation, how long
you're saying everything is
how real time does this data need to be? How fresh does this data need to be? That's what this is all about, dude. That's what this all boils down to. Because if the data can be a week old, you can use architecture from 1900, right? 1900. You know,
1930s.
Take oxes and have them ship your app around the world. So it's all about
the good old days of web development.
Sally was a good ox. If it all boils down to how fresh does this data have to be, and when you're doing CRUD operations, it typically has to be, well, not always, right? I mean, you can optimistic UI, you can use Git, exactly. You can use log-based stuff to anticipate. But at the end of the day, there are operations that basically need to go back to origin, and therefore there's a certain amount of freshness that needs to be there, and that's what has an implication on all of these questions for your architecture. And the question is just, what is the window for that? And does the Zeit architecture could potentially give you a shorter window where a bigger threshold?
I think I'm following what you're saying.
I need to think about it more because a lot of this is just new thinking.
The thing that excites me, the thing that got me excited about this conversation is that I can get to, I don't have to think about get initial props from the beginning.
Yes.
But it gives me but I'm thinking about the fact that I do have get initial props so that one day I can start to add those into my app.
For sure. It's again, the reason I wanted to walk through the two examples was because it's like, what which one is better? So, or which one is preferable, right?
Right.
In the Ember case, you are basically making changes when you have views that depend on real-time data. You're changing the ones that depend on real-time data. In the Zeit case, you're changing the ones that depend on stale data. So in the Zeit case, you start by default the client making all the requests, which works for real-time data. And when you want to cache something and make it fast, you move it to get initial props. In the Ember case, you start by making everything block on the client does request it, but once you introduce a server, the server requests it too. And so if a page can be cached, then you're ahead. And once it needs to be real time, then you have to move it out of the happy path of the app development. So when you move a data request from the model hook is the happy path place to put data requests, right?
Yes.
So when you do that and then you add FastBoot and a caching layer, it works as long as you can work with stale data, right? Because FastBoot blocks on that. And then it'll cache it and then it'll be fast, like our homepage.
Yep.
Right? But if you need a settings page and you don't want it to, the constraint is real time, you need to go off the happy path. See what I'm saying? How the real time constraint is what moves you off the happy path?
I know, but you could always have the model hook run for every single request so that if you request the settings page, the model hook is going to run in
How would you do that?
So you can do that in FastBoot. FastBoot would run the model hook for you.
You're saying like if is FastBoot or something like, or ignore this or something?
No,
but that's the same as making a component fetch data. You're changing the Ember app code to accommodate the real-time route. You see what I'm saying? Whereas the home page is going to work out once you add FastBoot app server and varnish.
I'm saying there's no varnish in front.
No, varnish is what it's all about, because why else would you render on the server? Why else would you render on the server unless you're going to cache it ahead of time?
Well, let's say that FastBoot got fast and we could generate pages.
That's effectively what I'm saying though. That's fine.
It's weird. It's a very weird case because it's
like
not realistic and you can't actually do it today.
No, but it's fine. It's just saying that no, I'm just comparing. Once you decide to you can server generate stale pages. Like the pages that you can server generate, server side generate, SSG, right? SSG with Zeit looks like
moving code into get initial props.
Yeah, for the data fetching stuff. Yes. Yep. SSG with Ember looks like doing nothing different. Like once you add FastBoot and varnish, then your Ember app code is not changing at all. So if you are thinking about the entire architecture, the architecture defaults to SSG every page in the same way.
Yep.
Whereas the Zeit architecture defaults to SSGing the app shell. So if you want your data requests and your dynamic parts of your app to take advantage of SSG, you have to make a modification. Whereas over here, if you turn on SSG, you break routes
the
that
model hook
depend
always runs.
So you break routes that depend on real-time data. You have to change the code there to accommodate for them. See what I'm saying?
Yeah, I do. Can I repeat?
Yes.
Okay, so in the next model, since your data fetching starts off in use effect,
yes.
If you want to get server-side generation of this data, you have to move it out.
You have to change the code.
Because use effect doesn't run on the server.
Yes.
However, in Ember, your data fetching starts off in model.
Yes.
And model does run on the server. So if you want to opt out of SSG, by the way, I like this term.
Yeah.
You have to find another way.
Exactly.
Component that fetches data and data insert element.
So the reason why I wanted to clarify all this is because we're talking about like which architecture we like better. And like when we were working on this, you were often like, yeah, the Ember model is so nice here, right? And the reason it's nice is because like you don't actually care whether the code needed to power and render this page is like a static like JavaScript code that's like in your template file or a data request. Because the model hook acts as a choke point, all of them are the same level, which is a nice mental model for saying what can we SSG basically, or SSR, but like, yeah, it's really effectively SSG because like we don't run the thing at runtime. But that's like a separate issue. So whereas in the React case, all effects are use effect. There is no subset of effects that is specifically about data fetching for this route. Whereas like you can think of model hook as did insert element, a very special breed of did insert element that FastBoot happens to wait on, right? And so
of use effect.
Yeah, exactly.
Yep.
Exactly. It would be like if you could mark the use effects that you want to block rendering this component. I guess that's what suspense is. So that's a good, interesting point with like next block on suspense boundaries. You would expect it to. Maybe that's more similar to the model hook, right?
Yeah, I don't know what would happen. I don't know if you
because then the code changes would look different. But
I don't know if the server would wait on a suspense boundary.
Suspense boundary says you can't render, or
you just render. You can render. Yeah, you render the fallback, and that's it. That's your render.
You would want to block rendering. You want to be able to block rendering. Like visit being asynchronous is good. Like you want that.
Yeah.
So that's what this all comes back to, and why you were saying things like what I really want is the Ember FastBoot model here, because you have a way in app code to designate what should block rendering this thing. And now with Zeit, you're kind of modifying, you're changing the architecture of your app. It's nice. The Ember is a black box here is nice. Now the con though is that what get initial props gives you is that that Ember doesn't is what does it get? I have a lot going on in my mind right now. The whole benefit of get initial props is when you want to
okay, let's get there.
It's just easier because you have
sorry.
This is the thing. Get initial props is literally a documented provided API for you to say this thing is like a real-time thing that should not block, cannot be SSG'd, and I want to wait for the client to make it. Whereas in Ember case,
bingo,
you're doing like if is FastBoot in my model hook,
the model hook always runs.
Yeah.
So you have to find out. So you have to,
or you're making a data fetching component, or if you're doing a Rails server, like you are doing all these other things. So the whole point is like if you want to ship half of your app and then let the shell run and then delay a data request until the client, once you've introduced SSR and SSG, it's way easier with Zeit than it is with the others, basically everything else.
Yep.
So that is the benefit.
Yep.
If these aren't in tension though, if React had a model for blocking rendering, then you could have the best of both worlds, it feels like, where you wouldn't have to modify your application code just to SSG it because you have a way to block rendering on async things that you've decided can be cached, right? So let's say you had a use model effect. If you had use model effect and
I just want to say, yeah, I do, and
a shoebox, basically a shoebox.
Shoebox is something.
No,
we add on it.
No, but it's the whole point is like it's not add on, because the whole point is like how can you get to a point where the app developer is writing app code and is not having to think about this, and they're not getting into a trouble spot where later when you add SSR, SSG, you have to modify your app code. That's the whole point, right? So Ember wins in certain cases, but in the case where you want to delay the request until the client does it, it loses, right? Whereas React wins in that case, but it loses in the case where you want to SSG, which is a lot of the pages, which is why you were saying like I really want the FastBoot model here, because once you want to SSG all this stuff or SSR it, then you need to start modifying your application code because you have no high fidelity way to mark which effects should really be blocking and really be a choke point.
Which are really part of the SSR output.
Exactly.
Yep.
That's why it's useful.
Yeah. As you were saying this, I don't maybe there's a way that we could get there with the React model, because we could always run a React app and
do whatever
JS DOM or in Chrome.
Yeah. That's what I was thinking.
A point. Like we could run an app and just say like, if the output hasn't changed,
we're not ready yet.
If the output is changing, we're not ready yet.
Yeah, exactly. Well, that's what my question was.
We can also
like,
be super naive. We can just say run a page and 1,000 milliseconds later, capture the output.
For sure.
And that's for all the apps that we work on, that's pretty damn close.
That's true. And then all that's going to be cached. And then for the pages that need it to be on the client, they'll just get the shell and then they'll make the request on the client. That's pretty interesting, dude, actually. So with Next, can you like...
We need like a use server
So
effect.
yeah, exactly.
I mean,
It's not use server effect though. It's well, yes. It's really use server effect is the first layer, and then model hook with shoebox is the next layer on top of that. If the server happens to have this data, it is a really good architecture. There's no question. The model hook on the router being a choke point, being able to share the data with the shoebox, gives you basically all the control you need. If Ember had a way to Ember just needs a better way to not block to do non-blocking requests. It's basically Ember concurrency. It's not that bad, I guess. So it's actually not that bad, but it's kind of like a big change when you go from fetching data in the route to like fetching data.
Yeah, it is.
Big change.
It is. It's
But like, and also Ember developers aren't thinking about that as like this data needs to be fresh or this data can be stale. Whereas like I feel like the get initial props thing is like you're thinking about this from the beginning. What can be fetched on the server or what can be cached.
It is perfectly fine that my client makes this request, so I'm just going to throw this fetch call in a use effect.
Yeah.
And that's just, there's no overhead there. I can think about it without, I need a term that's like, I can think about it without having to make architecture decisions right now.
Right.
So.
Right. It's not going to get you in a bad spot.
I really want to build the next app now.
Yeah, me too. I'm super interested. I
want
to read through the guides. I'm interested in it. Also, like I only literally haven't read anything on the Next website. I'm just talking about stuff that I've heard from like Guillermo on Twitter and on podcasts. So I could be saying so many wrong things this episode, but I don't. Yeah,
I think there's a lot of
We're talking about architecture.
Right.
Model hook is great, but it's also like really it's not named correctly. You really want to be whether you're doing the model hook in Ember or you're using an effect to fetch the data needed to render a page. You actually want in both cases something more expressive. So when I render if I render the home page of EmberMap and it can be rendered with stale data, like that is a fundamentally different model hook than rendering the settings page. And so you want an API to be able to express that, because then all of this server-side architecture could take advantage of that. It would be even less changes to your code. You see what I'm saying? So what I'm saying is like, why do you move a data request from the model hook to components? Because you don't have a way to tell the system that this is critical real-time data, and therefore, even if I'm ever in an environment where my server is pre-rendering my Ember app or rendering it with like cache data, to avoid this, because that's really what you're trying to say. See what I'm saying?
Yeah, I mean, you can do this with like if a model hook, if is FastBoot, return nothing else.
Yeah, but you want that to be
request.
A first-class API. Like you want.
What if you had like a model?
Maybe that's
hook?
not that bad.
Well, what if you had a model hook?
You could decorate.
Yeah, exactly. What if you had a model hook,
and then you could decorate it and say at real time, and then boom, all those model hooks are just avoided on the server. And
it's funny, at real time is not. It's not enough, because from the server's point of view, it's real time. It's like client.
No. Well,
I know. It's like client
at client.
Client. Yeah.
No, but the reason you're putting at client is because you want to deliver the shell as fast as possible. You want to deliver as much of the app as possible. It's literally just this code in the model hook that you want to wait and push off until the edge.
Exactly. So it's at not instant, something like that. The decorator is like this thing.
It's
don't let this
fresh.
block. Don't let this block you from rendering.
No, but the reason you're doing that, why are you doing that, is because the data needs to be fresh for the user. That's what is implying all of this. So
I know, but in both, like at fresh, in both cases, whether it's rendered on the server or the client, the network request is going to be made. Neither of those cases are going to read from cache. So I don't like at fresh because it's
No. On the server, you want to avoid. I'm talking about requests you want to avoid on the server.
Right. No. I'm saying like at fresh implies that it wouldn't be fresh. It shouldn't be used in an environment where it can't be fresh.
Right. Exactly. What you just said.
But
that's true, though. It should not be used in an environment where it can't be fresh, which is the server.
it can be fresh on the server.
No,
it
well,
just would. It
no,
just
you'd rather
delays the app
yeah,
shell.
exactly.
So it's like at don't delay the app shell.
Yeah, it's just you need origin at runtime, basically. It's like, do you need to hit the origin at runtime? And if so, boom, like
Let's let the client do it.
Yeah.
Because the server is really, really great at generating stuff that doesn't involve the origin.
Exactly. But at origin at runtime is different than like I need to make an asynchronous network request. Whereas in React, use effect is the only thing you have, and that's why you can't say some asynchronous things need to hit the origin and some don't, and the ones that don't, go ahead and SSG them for me when you're doing your server stuff. That's why the model hook is so good. But you want one more piece into it, which is hit origin at runtime, and therefore don't hit it any other time. This is like a thing that must go to origin for the user, therefore don't run it until the user is looking at it, basically.
Yeah, it's really don't run it on the first render because I want my first render.
It's run it on the last render.
Yeah. Because I want my first render to be like get me to time to first byte, time to first paint as quick as possible.
Yeah.
So that's basically SSG.
Yeah.
That's app shell.
Yeah.
And then
this is why get initial props is bad, because get initial props is effectively use server effect.
Yep.
Right?
Yep.
Get initial props is use server effect that blocks the React app from rendering.
Yep.
But you don't want use server effect, just like you don't want server model, because you want the same code to power. You want a place to say what request powers this page in both environments. It's just you need something in addition, which is something that says I only want to run this in client. You know. Mm-hmm. You really want a block router effect, block rendering effect. Use layout effect if it stopped the React app from returning, and you would use layout effect for all your data requests. And that way, when you transition on the client's making the data requests. If you SSG on the server, it's going to block on those data requests, and then you actually use effect when you want to go to origin on client only, and then server rendering.
I'm having such a hard time. You should just make up new effects because I'm trying to map.
I gotta write it out as a thing,
and
it's really use blocking effect. If you had use blocking effect and the React community was taught to use that for all data requests, it would be a similar thing. And you had Next architecture, then you have a really smooth path to SSG and SSR. And you also still have a way to put off critical real-time data requests to the client until the client is finally rendered on the end user's device. That's really what I want.
So in your world, I would use blocking effect
for all
data fetching, and that would cause those effects wouldn't run on the server, but they would run on the client.
No, they would run on the server. They run both.
They run in both, and then when I need a data effect that shouldn't prevent app shell from rendering, what do I use? I use something else, right? I use some other effect.
Yeah, you just use a normal effect.
Okay.
Yeah.
Okay. Because normal effect is already client only.
Yeah.
I mean, couldn't you just say like, well, you do have that. It's called get initial props.
No, but when you start working on a new React app, you don't put all data fetching code and get initial props. Also, doesn't that only run on the server? So once you have the React app and you click on a link to go to a new route, you're not going to use get initial props. See what I'm saying?
You want the thing that starts off by running in both, similar to the model hook,
exactly.
And then you
progressively decide
when to split.
Yeah.
Where the next model says we start off by only running on the client.
Yes.
And then if you
progressively speed up things by
adding it to the server.
Yeah, exactly.
Yeah, that's interesting. I don't know which I prefer. I think
Well,
I'd be
prefer-
okay. I think I'd be okay with either.
If you want the one with the fewer changes required for your app code, right? And so,
Yeah.
that's the thing. With React, fetching data in an effect is how you do it. If you could just switch use effect to use blocking effect, that would be a very small change. Whereas in Ember, fetching data in a model hook is great, and then switching your app to work where it doesn't do that is a big change. It's not a smooth transition.
Right.
But now,
even if it's minimal code, it's still a lot of decisions.
it's a lot of decisions, yeah. And you're not using the router anymore, so you're losing a lot of the template conventions and the controller stuff.
I have a question now.
Also, the suspense, it's not really fair because the suspense stuff is, they're not going to come out. The reality is they're not going to come out with use blocking effect, and therefore it won't be a one-line change to your data fetching code. They're coming out with suspense, which is a bigger change to that. That's how you communicate that this should block rendering in some way. You could imagine a suspense boundary with like no fallback, which is like a way to tell React, you can't render this until this is all resolved or something like that. I don't know. Just guessing at this point.
I have a question. So part of like Zeit now, Next, their whole thing is like have a fast app. Speed up your app.
Yeah.
Use these tools and you'll get a fast app. So it seems like in their world, since use blocking effect, it would actually slow down, by default would actually slow down your app because you couldn't render an app shell if you have use blocking effects.
Well, you could if you cache it. Like you wouldn't.
I know, but their whole thing is like really, really, really fast apps. So like,
even if you don't have a cache.
Yeah.
To me, I guess in my mind, like cache is what makes it. You don't want to rely on runtime server like running you don't want your server to run your React code at the time when the user clicks a link. That feels slow to me. I don't know. I want to get the React code.
To me, that's like a black box.
Yeah,
that
I guess
could be
so.
sped up. So that's like out of my. Like that's not a concern.
I just feel like the cutoff is whether the data can be fresh or not, and once the data has to be fresh, you request it on the client, and everything else can be like cached and rendered and cached at the edges, and it doesn't matter.
I know, but if you start again in a world where you want to encourage people to be fast, if you start off by requesting data on the client, it basically makes app shell generation really easy, and thus nudges you towards a fast website because it gives you a server render that generates the app shell.
Well, what I'm saying is that like you would be faster because your server would be able to SSG not only the app shell but the data too. And in the event where you need the data to be fresh and not cached, then you don't use blocking.
No. So that's that's where we're attention because
you're saying the first initial run without the cache, like a cache miss?
No. In your world,
you
use blocking effect.
Yeah,
it runs on the server. Yeah. Let's say that's really fast. It takes like 50 milliseconds. Mm-hmm. You still, like when I make a request to your website, I still have to wait 50 milliseconds because on the server.
No, but if it's cached, it would be in the payload that is served by the same thing serving the way it's the EmberMap model.
Okay, but
that's what I'm talking about.
But caching, like we can hand wave with cache and solve
a lot of things.
Anything. Like
no, but that is how EmberMap works. It literally doesn't matter that the model hook could take 8 seconds or whatever.
Yeah,
right. To me, that's like good architecture.
I know, but there's a whole bunch of other. There's a whole bunch of decisions we have to make. I'm saying by Zeit encouraging you to fetch data on the client is their default happy path. You get
an app shell fast, but you do not get the FastBoot behavior where once you
correct.
Yeah. So,
but because you can app shell fast. Also, I don't know if I believe this, but I do want to make this argument.
Yeah.
Because you can app shell fast, you're encouraging people to make fast websites.
I don't know if that's true. Is it really fast to see a loading spinner for 30 seconds when there's no reason your architecture couldn't just nudge you to make it so that you cache not only the app shell, but also the content that can be stale. That's what I'm saying is the important distinction, that the app developer be thinking about what data can be stale and what data must be real time. And to be able to mark that in a way that the architecture can take advantage of. Mm-hmm. If Next and Zeit can pre-render your app shell, why not pre-render the parts of your site that can be stale, like a blog?
Yeah. That's fair. Imagine we could snap our fingers and there was like,
and there was
a great data fetching library that's like server-side cache aware.
Right, exactly. That's the thing. Like now they have SSG for Next, but how do you do it? You move the data fetching into get initial props. If you wrote a blog in React and used effect to fetch the data for the blog and then tried to layer on SSG, it wouldn't work. You'd have to start re-architecting your app to move the data fetching into get initial props.
Yep.
And now you're tied to like Next, and there's nothing in your code, in the React code, that comprehends the fact that this should like block anything anywhere. It's just all the same. There's one kind of effect. Whereas really there are different kinds of effects in this when we're talking about data fetching. And if React had a way to say like there's a certain subclass of effects that we wait on.
Okay,
or like even get initial props is like kind of, it's just dumb because it's not part of your React app. It's outside of it. So Zeit can choose to run that first and then render your React app. But like you really want, I guess it's pretty similar to that. I guess if you're building, the problem is like you're building a Next app and it's not just a React app anymore. That's the thing that's bothering me.
Is there something fundamental here that if we have components that can suspend and not return anything,
could Next deprecate? Could Next deprecate get initial props and use suspense boundaries instead? That would be the interesting question.
So you would put all your data.
Is there a way to suspend?
Wait. So
it would basically be Ember. My suspense boundary says if I'm on the server, then no placeholder, no fallback, and therefore block rendering. If you could do that, then Next doesn't need get initial props anymore, right?
Because you're going to force that effect. By the way, we don't even know if suspense runs on the server, but you're saying imagine it did.
Yeah, I'm sure it does, but I guess we don't know. I'm just guessing. Then you're basically at FastBoot model, where suspense boundaries with no fallback act like model hooks that completely block rendering, and then you can put conditional logic in your app that says whether I'm on the server or client. And now we can also talk about this layer on top, which is really like a @fresh decorator. It's something like that where you're saying, oh, this boundary this promise that we're throwing is actually like a fresh data thing. And so now the architecture can just say, okay, we'll ignore that one on the server. And then that's the level I want to be thinking at, because that's the level the app developer should be thinking at. This dashboard can be cached. It's okay. That's a little stale. But once you go to the user's page, it needs to be fresh.
I think one of the things too is you're saying that once you have this, you can layer in caching.
Yes, that's the whole point. That is the whole question. Get initial props is a different level of abstraction than your application code. The whole question here is an app developer building an app, being nudged in certain directions. How can you, what APIs, what is the application APIs needed for an architecture like Zeit to have enough information to know what to SSG and SSR and what to push off until, basically SSG and what to push off until the client. Like to make things simple, like what is stale enough that it can be SSG'd, and then what can be put off until the client initializes. So something like that.
This is good. I never really thought about like all these ways to think. I mean, I clearly haven't thought about all this, but it's
well, we've thought about it. We just haven't had names. We haven't really clarified it.
Having great APIs to defer rendering until the client.
Yeah. I mean, literally, what do we do in the header for EmberMap once we introduce caching and FastBoot?
What do we do in the header?
What do we have to do?
It's like if FastBoot, you're not going to have the data you need to render this.
Yeah.
So render placeholders.
Yeah. At the template layer or something, or component layer or something.
I mean, unfortunately it's all over the place because we started off with an application hook that fetched some data.
Right.
But that can't run in FastBoot.
So that's exactly what kind of thing I'm talking about. Is like, see what I'm saying? What are you taught to put your data fetching code, and how does that help you fall into a natural pit of success when it comes time to cache, when it comes time to layer in fast in performance, or when it comes time to deploy to an architecture provider that is focused on that?
Yeah.
How much can the architecture do for you based on how you've annotated your code? Right. That's what we're really talking about here, and Ember's FastBoot architecture can do a lot for you, given that it knows the model hook in general is a choke point. But then there are these cases where, if most of your routes can be cached and can work with stale data, the Ember architecture is great actually, And then if it's half and half, you're going to be changing a lot of code, right?
Mm-hmm.
Same with React. If most of your code needs to be dependent on runtime, it's the flip, right? If most of the code needs to depend on runtime, it's going to be great about giving you that app shell really quick. And then React on the client will make all the data requests. But if you want to layer in pages being cached, you now have to refactor your app code to use get initial props, which is like a weird thing. And I'm saying there's no reason you couldn't come up with a higher level thing that makes sense in the vernacular of the app developer, where they can annotate which code needs to be like that from the beginning, so that when you add these architectures, you don't have to change the app code as much.
This is great. I just want to kind of just end with one thing.
Yeah.
When we were fast booting EmberMap, I have this it's a decorator like thing, pre-decorators. It's called rendering context, and you give it a hash with server and client, and those are both functions. So I can say model hook rendering context. That's an object. That object has two methods, server and client. In FastBoot, it's only going to run the server code, and the client, it's only going to run the client code. I wasn't thinking about this conversation when I wrote that. I was thinking from the point of, I can't run this code in FastBoot because it uses window, or I can't run this code in FastBoot because
it's slow.
Yeah, it just doesn't. That's not what I'm trying to accomplish here. I'm trying to, this would make more sense to run on the client. Right. But I wasn't thinking about
stale data right at this level.
But I think if I went back and I looked at that code, we would see a lot of this conversation showing up, how I'm using that client and server function.
Yes.
So I really like, just to echo your point, giving equipping the application developer
with the vernacular and the vocabulary to be thinking about that. Totally. 100%.
Dad, I wish we didn't have all these websites to maintain so we could just go off and build a Next app. We got to work on EmberMap, we got to work on Mirage.
We can rewrite them both in Next this weekend.
Yeah,
right. Pretty interesting stuff, man. I feel like the FastBoot architecture is super interesting, especially if someone has only ever done React or something without more structure to it. To see that you can take an app that was written on the client and run it as a black box on the server is just super powerful.
Yep.
But it still doesn't have the granularity that we want, right? That this conversation kind of exposed, which is that really the app developer, this is really what it boils down to. The app developer is in the best position to know whether a particular data fetch needs to happen at runtime, or it can be cached. It can be,
That's great, because that is true for every app. If you think about a Rails app, the app developer knows
totally
that if this SQL query can be cached, or if this should run.
That's right. You're layering the caching stuff in the template and in Rails with the Russian doll stuff. So it's an acknowledgement that should live there. Super interesting, actually. And then you just don't cache things that need to be real time. And the app developer knows that.
Mm-hmm.
That's pretty interesting, actually. I hadn't even really thought about that as an analogy. But so the Rails model is more like the React model.
Sorry, my brain is.
I know. The Rails model is more like the React model, which by default everything happens at client time, and as you layer in speed improvements, whereas the Ember model is everything happens at server time once you introduce FastBoot, and then you have to opt out of things running on the server if you want to push them off until the client.
Yep.
So if you want the freshest thing, Rails is by default going to wait, and then you layer in caching by adding in the Russian doll caching stuff, which is a super awesome API. Talk about expressive.
It's really
this
good.
Chunk of the template is busted when model ID 5 changes. That's really good.
Yep.
Think how much advantage the architecture could take advantage of there. Everything not in those needs to go to origin. But like you said, these providers and stuff.
And this is the beauty of freaking running React components on the edge, because Rails templates, they just run on one server.
Exactly.
But imagine you could break that up by component.
Exactly. That's that we need, the level of expressivity in in the app code, in the templates, in the JSX components, whatever, so that the tools can do this really cool stuff. Right now, everything's in effect. It's not enough. It's too blunt of a tool to make data requests with. And like get initial props is like, oh, we'll just give you a function to do that, but that's like still not enough, right? Just like the model hook is not enough. You know what I mean? Anyways, pretty interesting.
Try to think what apps can I build? What apps can I build?
Well, you want to build an app that the real way to test this is like an app that is like, yeah, EmberMap is a pretty cool example, or something that's like a content site that is like, or a blog. A blog, a personal, your homepage, your personal website, which has stuff like a blog, which can be cached, and then stuff like what are my latest GitHub stars or my follower count or something like that. That's real time.
There is an app. Yeah, it's an app that has both. I mean, dashboard app is pretty cool because you're going to have stuff you want to cache in there.
Exactly.
And
have stuff
server generate SSG.
Yeah.
Blog feels like it's like all cached, all build time. So,
blog, I mean like RyanTransfer.com will have a blog, which will have cache stuff, and then it'll have
some aspect of real time.
Exactly.
Yep.
Overview or your age that fetches from the server or something. And it needs to be real time based on a serverless function.
Can't derive it from birth date either.
Yeah, exactly. Totally not. You have to add, make an API endpoint. Actually, that would be a way to do it.
What?
You have to hit an API endpoint that just calculates your age at request time.
And the request also sends over the current time.
No.
Right?
Oh, yeah. Yes. Exactly. Yes.
Well, we need to end this.
Pretty cool, though.
So since we talked for like 2 hours about Next, should we just plan to carve out like a good 15 minutes for all the corrections we need to make next week?
The amendments. Yep. Once we actually get around to trying it out. Anyways, we didn't even talk about the other interesting thing that happened, which was why we were deep diving into Next in the first place, is because those bastards swap out a module in your build tool if it happens to be something that sounds like a polyfill, even if it changes the behavior. So that was interesting, and that's what broke Mirage. Why there's not like a easy way to use Mirage with Next right now. And we actually have a fix coming for that pretty soon, I think. We know what it looks like, and we think we can fix it. It has to do with some of that stuff upstream in Pretender. So we are hoping to have a quick start guide for Mirage and Next very soon. It's really important to us because we've had like 4 or 5 people ask, which means there's like 20 people who have tried or 30 people and haven't found an answer. It's Next is definitely popular. So
yeah. And going back to the onboarding. Yeah. I think that's, I don't know. I think that's one of the reasons.
That's really cool.
But yeah.
Awesome. Well, hey, if you stuck around this long, we're going to send you a Reese's peanut butter cup. So just tweet me with your address, and we'll send you a Reese's peanut butter cup.
Yeah, we can commit to that.
I'll do it.
Yeah.
I will pay someone to do it. I will do it myself. We'll do it. But if you stuck around with us and give me your personal information, your social security card, your first uncle's name, your name of your pet, name of your best friend in high school. What was that movie 21 with Kevin Spacey where they like, did you ever see that? Kevin Spacey, they're like counting cards in Vegas and stuff like that.
Oh yeah.
And they asked some guy that they end up hustling, like, oh, your uncle's name, and oh, what was your first dog's name? But they're on a plane and they're like slowly asking him all the security questions for a banking login so they can get it. They can get it.
There's a great, by the way, you can just stop listening. There's a great tweet that's like, your hacker name is your favorite sport plus your mom's last name.
Oh, and it's trying to get people's passwords.
Just like everyone always replies. They're like, oh, so cool. There's like, there's 75% is like, oh, no one fall for this. Like,
right. Just because that's a common combination for passwords. Right.
Yeah, security questions.
Oh my gosh.
Dude,
I see. See, dude, I would have been the one who did it because I didn't understand. It's 2 security questions.
Dude, let me rail.
That's so funny.
Dude, United.
I'm so clueless, man.
United Airlines, you have to freaking answer these questions when you log into your account to book flights.
Oh God.
It's incredibly, it's just why to book a flight.
people are just using randomly generated passwords on 1Password now for all the security questions.
Oh, cool.
And just save it and just mark it as a thing. And that way it's not remembering anything. You're just using it as a password the same way you would your other passwords.
One of the things that drives me crazy about United is that they do not ask, like, I'm going to call them like fixed security questions. So like an example of a fixed security question would be like, what town were you born in? Right. That doesn't change.
Yeah. Oh yeah. They'll say, what's your favorite fruit or something like that?
Yeah.
Oh yeah. That's ridiculous.
Or like, what did you eat for dinner?
Yeah.
Like that's
ridiculous.
So like, not only are they asking these awful questions, but you have to answer them. So I think I just have like I was going to say, like, I think I just have an answer, just no matter which one I select, it's always the same answer.
Yeah.
I don't really want to say that.
Yeah.
Someone's going to book flights and get me mileage points.
Nala.
Yeah, basically. Yeah, that's it. It's one of them's what's your current pet name?
Oh.
And so it's like you're going to have like
different pets in life. Hopefully.
It needs to be like, they have to be fixed.
Yeah, that's pretty dumb. Cool. Again, if you stay with us, we appreciate you.
If you made it this far, you get 2 Reese's. All right, let's wrap it.
Let's wrap it. Thanks for listening. We'll see you next week. Bye-bye.
Bye.